Hello, ladies and gentlemen, and fellow PMs. Today I'm just recording the MEP connection videos because last time when we did the little meeting, I simply forgot to record the sound, so I have to record it again. This time I am a bit more prepared, so it's a bit less messy. So hopefully I will be able to go about everything that is possible. So here you can see I have prepared a little room with some three types of MEP systems, so electrical one, duct one that I call ventilation, and the plumbing one, which is basically the three main type of MEP system in Revit. So as you can see here, you have sources of the system and basically the terminals, and basically in Revit you go from the terminal to the sources, so that's why it's important to differentiate both, and we will see that it is also important to have this difference in the connection. So I will simply here hide the walls and the ceilings that are not really necessary for the presentation here. Okay, so first we will start by the plumbing, which is the one that we have the most here when we do some content. So basically we have no connection in this in every object that we have in the project except the equipment, so we will do here the connection of all the terminals. So as you can see here, there are 5 types of connectors, the electrical, duct and pipe, which are to me the main ones, and those ones here, cable tray and conduit, are for electrical stuff but don't really hold electrical data, but we will see it maybe if I don't forget at the end of the video. So here this is sanitary, so we will have to create a pipe connector. So the pipe connector basically can be phase-based, and is mostly phase-based usually, but it can also be plane-based. So every connector has coordinates, as you can see here, X, Y, and Z. XY is usually the face, about the face of which the connector is implemented, and it should always be in that sense basically. So if I am perpendicular to that face, the X is to the right and the Y is to the top. That means that the face is actually in the right direction. Sometimes the connector is in that position, which means basically that it is upside down. The Z is in the right position, but the Y is to the bottom. I do not know if this impacts calculation, but every time that is possible, have the X to the right and the Y to the top. That way, basically, you have the face that is, you basically state that the connector is in the right position. The Z here should always be perpendicular to the face, obviously, to the exterior side, because it's the direction of the geometry of the pipe or the duct or whatever. This is not the flow, this is really for the geometry. That means here that the connector and the pipe will go to the outside of the connector. So when we have done this, here I can click on the connector, go to the properties, and then I have different information. So obviously I have the diameter, because pipe is usually and always even circular. So the diameter can be here a parameter. But in this case you don't really need a parameter, because this will not be changed by the user, so I can input it directly here as a value. So this value I will put it as here, sorry, as 15 for that one. Sometimes it is 20, and for the out part I will simply put it as 100. So when I have done this, to be sure about what value you have to put at diameter, you will need to go check on here nominal diameter size. Maybe I have it, yes, okay. So you go into Wikipedia, for example, and the nominal diameter size here is usually the inner dimension, opposed to the outer dimension. This is here the imperial units, which are fractions, and this is the metric ones. Basically, in France, when you have some supply of water for cold water, domestic cold water, it's usually 1521 or 2027. This is all into the technical sheet of the object, and this is the value that should basically be told by the manufacturer, so you can input the proper information into the connector. And as you can see, you have the bigger ones. That one is usually for waste stuff. So now I have the proper information here. Oops, sorry. So I can go on. Now next is the system classification. So the system classification have two types, basically the normal ones and three specific ones, which are domestic hot water, domestic cold water, and sanitary. So before I go into details, I will just say basically what they do. Hydronic supply and return is for water that is not for human consumption. Basically that goes into heaters, for example. Sanitary is for waste, vent is for ventilation, domestic hot and cold water is water for human consumption, basically. And those will go into kitchen or bathrooms, for sinks, for toilet, etc. Other, we should avoid that one. Fire protection is self-explanatory, it's for sprinklers, fitting for fitting, obviously, and global. We should also avoid using that one, but sometimes it has to be used, for example, for valves. Usually they are done as globals, or for maybe sanitary accessory, they are done as global. But mostly the most interesting one for sanitary will basically be domestic water and sanitary. So why are those three specific here? Because if I select those one compared to, for example, hydronic return, as you can see, there is a parameter that does not display anymore. That parameter is fixture units, which is a parameter specific for sanitary stuff, and basically is about units here that are value like 1, 2, 3, or 4, and are corresponding to a specific type of flow. So I do not know more about this, but basically it's mostly North American from what I understand. But even sometimes North American doesn't really use it too. So we won't necessarily use this, but just for explanation, when you want to use, if a manufacturer wants you to use fixture units, then you have to change the flow configuration here to fixture units. And when you have done this, then that one is no more grayed out, and you can then link it to a specific family parameter that are already existing. You do not need to create another one, you link it to that one. This one basically is cold water fixture unit, hot water fixture unit, and waste fixture unit. That's why those three are specific, because they are already available for fixture units. So when you have done this, for example, this is here, so I have a waste fixture unit for that one, even though it's the top one, but it's just for show. And when I have done this, then basically I can drive the information from these three parameters. But most of the time you don't use it. So first let's unlink this, just to be sure, and then put the proper information. Yeah, so this is here domestic cold water, and we will not use fixture unit here, and we will use here a preset flow configuration. Preset simply means that there is information regarding flow that is already set into the object. This is most of the configuration that is mostly used for sanitary, and sometimes it is system. I do not know how this works with it, but I guess that it divides the flow information in the system by the number of devices, but I'm not sure, so do not take my word for it. But calculated, for example, is for the equipments, for the sources, because basically in Revit, as you go from the terminal to the sources, it will add the information for all the connectors of the terminals, and then show the total into the equipment. So that's why calculated for sources and preset is for terminals. So here I am preset, and this is good. For that one here, I will put it as waste, because this is sanitary. and then I will set it at preset 2. Now that I have set the proper flow configuration, I can set the direction. So the direction has absolutely nothing to do with the direction, except that it takes the same vector, well, the same plane, you know. So it's either perpendicular to the z or parallel or the same direction to the z. Here it's simply where it goes. So it's inside, you know, it's in, so it's okay. That one goes outside, so it's out. So it's pretty simple. Then we have the loss factor. So when it comes to piping, you always have some pressure in it, but the pressure doesn't stay constant within the piping. So there is always the possibility to have some calculation that take into account this loss of pressure. So you can either do it as a K coefficient. So basically you link it here with a parameter that you call K coefficient, or you can have a shared parameter that's already set up. But for the sake of this video, I will just do it as family parameters. But I do not use K coefficient because I do not know what it really do, but I guess similarly to fixture units, it will be a coefficient that will decrease the flow from the beginning to at the end. You know, usually what you do here is specific loss. So specific loss here simply allows you to do a pressure drop in Pascal. So this is mostly how it is used usually. So that's what we will use now. So now we have set up everything that is about the flow, the basics. Now we will go into the dimension. Here everything is set up properly here, except here the loss factor, which I will do. And I have also, that I forgot, the here stop adjustment. So that is mostly for fittings that allows some slope adjustments basically. So sometimes you have a fitting that has a specific angle and you can have a tolerance for this angle, so this is mostly what you will check when this is the case, but for that one we don't need to check anything here. So now I can go into the flow, and the flow will be a parameter always. So not only that it is always a parameter, but it is always an instance parameter. Why? Because we do not create a type for each flow variation. So I can have 5 parameters and I will not create 5 types of flow. It is not intelligent, not smart. So this is a instance parameter, and I can also have that one as instance. So sometimes it is the same, but for the example I will simply do it like that way, flow out, because obviously the flow that goes into the sanitary is different than the flow that goes out. You know, that one is far bigger. Here it's the logical thing to have the flow in and the flow out. So you can name it however you want, but here I will just name it that way. Okay, instance, and I will do the same for that one too. Put it as instance. Sorry, here, instance. Okay. And then I will do the same with the loss factor. So the pressure drop here is sometimes not really used by a user, but it's always good to have here a parameter for it. At least your family is properly set up for the user that want to go into details and calculation, etc. So I will simply do one because I'm not sure that pressure drop can be different from the in and the out, but for better family making, sometimes it is better if you have in and out. But that one, for example, if I have put it that way, it can be too much, maybe, because it's not necessary. So I can simply go out like that, in. Oh yeah, sorry. And you have to put some brackets because don't remember. See, okay. And that one. So like that, you know, for example, if it's the same in and out, I just change that one. But at least it is properly set up in my family, you know. So at the very least, I'm okay with this. So this is not the case here. So I will apply different flows into the connector. So now I have done everything right except here, put some pressure drop here. Okay. So now that I have done this, I basically done everything that I could on the connector except naming them. So it's quite important to name them because most of the time the MEP engineers work in plain view. And in plain view, you don't necessarily see the different connectors. So when you have the name, basically you can identify them more easily. So obviously you can see that here, when I'm in plain view, this is the domestic cold water, and that one is the waste. Obviously you can also see it that way, but sometimes it's good to have the name. I believe it's a better practice that way. So now I will simply put some default value. So I believe that one is usually like something like that, and for out it's probably something like that too. For pressure drop, I do not know about this, to be honest, so I will let it at 0. So here I am okay. One last thing, connector can be linked. This is mostly when you have two connectors that basically have the same information and are mostly the main route of what it's, I believe it's the main route of the flow. So you link them, you know. So for example, if I do this and no, sorry, click on that one, I can link it, and there will be some. If I click on this, you know, there will be some arrows here, you know. So if I do this, it simply means that this is the main stuff, but this, you don't need to do it for that one. Usually it's for fittings or maybe for some equipment when you have the principle, the main the main flow that needs to be highlighted that way. So now I'm okay, and I load into the project, and then it will be, I will overwrite it, the value, and then I will see that I have my connector that are proper. So I have my flow in and out for all. Okay, that is good. And now I can create a system. So I will just simply go here. But before, I will just show you when you are in plain view how it is when you have several type of connectors. And here, as you can see, I will mostly I only see one. So if I go into connect into just to see the available connectors, you can see here I have the type, you know, with the geometry and the diameter, and also the name at the end. So if you have, for example, 3 connectors that are for sanitary and 3 that are for domestic cold water, you know, it's always good to have some kind of name so you can see them and separate them in plain view. So here I will stay in plain view and do my piping system. So I will select them like that way. Here, piping. I will do the domestic cold water. I open in system editor, and then I have my system. And after I does this, I click on select equipment. So here I will use an external connector. Because it goes out of the equipment. So this is okay. I finish it, and now I have, if I tab several times, you can see here on the system. So this looks good, and also now I can go into my UI and click on System Browser and see here the information about the specific system. So this is okay. I see all the different value, and that total is a bit weird. It should read something like 0.45. I do not know why I have that one, to be honest. Maybe it's because I don't know, it's weird. Anyway, here I will simply then click on the system and generate some layout. So this is simply Revit way of doing it automatically. Or for example, I will do one that is a bit clean. Yeah, that's look okay. Blue is main branch, green is secondary branch basically. So when I'm okay with this, I finish, and then when I've done this, okay, I have everything that is set up properly. Now I can even inspect it, for example, just to show the flow in it. And as you can see, you have the proper direction here. So this is the right way. And then if I go into this pipe, you can see the proper flow. So this is 0.5. And then it's actually 0.45, I believe, because it was 0.15. And yes, you have 0.3 here. And here 0.2, but it should be 0.15. That is simply rounded up. But you can see basically here on the branch here, everything is okay. Okay. And even at the end, if I am not sure about the sizing, I can basically here go into this, the pipe sizing, and it will do the work for me. So I do not know the speed that is in the piping, to be honest. I will let it that way. And here I will just do this, and it will reduce the piping accordingly to the flow and the velocity of the flow. So basically this is it for plumbing. It's quite easy, and as you can see here, if I click on that one and I go to property, the flow is 0.45, which is basically 3 times 0.15. So that's why, and if I go into that family, you will see probably that connector is calculated. That's why if I go, I don't know which one it is, to be honest, but you can see calculated here, domestic water calculated. So really, that's why you have connectors as presets, and you should really try to have them that way. So sometimes developers forget about it. So if you want some quality in your plumbing fixture, then then try to remember this. So now we will go look to ducts, and it's quite similar to piping, to be honest. Here I have some, I do not know what this is called, to be honest. Some stuff that do the air conditioning. I do not know the name to be. And here you can see, oh, that one is one for, I will put it on 40 with the same value. There are already some value here as a flow, so it's good, but there is no connection. So I will create the connection live. So just changing the value so it is the same, and then I will go into the family and create the duct connector. So this is a phase-based family, obviously. So I need to go below like that, and I will simply created a connector. So I will just select that faces, and as you can see, the Z is okay, the XY is okay. So I can now go into link the connector with the proper parameter. So if I click on that one, I can see that I can have different shape. It's rectangular usually, but it can be oval or circular. Then I will link here. Oh, but this is really good because I have already some parameter in that family. So I need the height with the hauteur, which is height, and the width with the larger, that is width, obviously. Now that I've done this, then you have the same type of settings that piping. So it is a terminal, so I will put it as presets. And then I will, oh sorry, I haven't selected this. I will put the flow direction. So obviously we should always avoid bidirectional. I didn't see that option in piping, but it is always possible. But you should always try to avoid this. And here it is actually a in, because it's a supply, so it goes inside the geometry. It's a bit weird, but even though it blows some air that goes out, the connector, it goes in. So this is not exhaust air, this is supply, so it's quite self-explanatory. Loss method, same, I will do specific loss for the same reason that we did in the pipe. So I already have some preset parameter, this is good, and I have here already some parameter which is also good. And then I will just put connector because there is only one, so it's not like I will be confused by several connectors here. So I'll make sure that everything is okay. Supply, so this goes in. This is everything is good. So up, I will load it back into the family, and we will do the same, create a system. So it's really similar to piping, duct. So saying, I create that one, for example, I can just simply use one. So it's a soufflage, which is basically blowing air, supplying air. So I open it in system here. I add to the system all the terminals. And now that I am okay, I select the equipment. So everything is good, it is here, and I can finish here. So now I will look into my system browser, go, supply here, and here, well, the total looks okay. You have the sizing, you have here 3 times 83, which probably does 249. So everything is good, and then I will do the same, and I will select the system and generate a layout. So for that layout, it's not okay because I have some yellow. Yellow basically means that there is not enough room to create the network. So I will change that one, maybe do it as parameters. Okay, this seems okay here. Okay, so we will use that one. And then finish the layout. So this looks good. Yes, this is great. And I will do the same. Okay, so first I inspect just to be sure that everything is in the right direction. So as you can see, the air is supplied here, then it goes there, and then it is blown into the room. So same, I look at the value, 166, it's normal because there are two branch, and that one on that branch I have 83, and for that one I also have 83. So everything is good. I will try maybe do some optimization on my sizing of the system. So there I do whatever here because I really do not know the proper value. I am not an MEP engineer. So I'd say okay. And once I have done this, so this looks okay. No, that's a bit weird. Yeah. Oh, okay. Well, let's just say that sometimes Revit does some weird stuff. But let's just say that it is good for the video. But I strongly believe that this is not okay here. So we are good on the duct system. One thing here, we see a different color for that one. I can select the system here and then edit the color of the system. So as you can see here, when I click on the system, it directly selected here, and so I can basically do the same and select the system that way. So it's easier to have the system browser when you do MEP stuff. So now I go into type here, and I go into graphic overrides, and maybe put it as orange. Okay. So like that, all my air supply families system, will be orange. Okay, so I believe this is okay. And now we will finish with the electrical stuff. So the electrical stuff is a bit different than those two. So we will go a bit more in depth for that one. So here I have some lights, and I have this is not an equipment like those one here. This is what you call a panel, electrical panel. So the panel already has some kind of distribution system. Just for information, but this is really not the point of the video. But if you go here into this, no, I don't care. You have different screen. Okay, and on the wiring here, you have the voltage definition. We simply state that that voltage here goes from minimum to maximum here, that one minimum to maximum, and that voltage here is linked to a distribution system. So that's the distribution system here. For example, mono means simply single phases, and 230 voltage simply goes to the voltage definition that was set here. So if sometimes you have some issue trying to do some electrical setup, is because you do not have done this. But here on that one, it's already set up, so it's all good. The phase here we will talk about because it will be really important. And the wiring, I do not know, so I don't care. So yeah, I will go into that family. So it's a phase-based lighting fixture. And as you can see here, you have an IS file. When you have a faceted yellow stuff, yellow geometry like this, is definitely an IS file. Because usually the light sources, are quite more solid when it comes to the geometry, So that IS file is already set up. I have the name here. So as Jackie pointed out in the video that we had, usually you can put some sentence here, for example, generic stuff here. So you force the user to download the IS file and link it afterwards. But for this video, this is not the subject, but we will maybe see in another one. So now I will create here a electrical connector. So I will go below, wireframe here, and then look at the faces. Oh, it doesn't want to. Oh, it's a bit weird because it's not really the faces that is okay. Well, because oh yeah, it's a revolve. Okay, so a revolve basically it's not really good to have faces, but anyway, it works. But usually we should try to in that case maybe do it as plane base, because if you do the connector as plane base, it will be in the middle of the plane, so it will also work. But anyway, this is okay. So for electrical connector, you have two types of electrical connector basically. The connector for information, so that is communication, fire alarm, security, data, and for power, those two one. The information here do not have any kind of info except the description. So here you do not have much to do else when you have something that is not about power. There is only one thing here that is utility. It is for all connectors, and basically it's for when you do some fabrication stuff, and this is really not what we do here, so we never check this. Anyway, if I click on power, we have two different type of power, balanced and unbalanced. So as you can see, unbalanced are different phases, and basically this is the difference between power for residential and power for industrial. What are phases is basically the difference between single phase and in French it's monophasé and triphasé, which is basically single phase and triple phases. And for example, if I go into images, we can see here. So this is actually a good drawing here, and you have on the left here. For that one, I will simply open the picture. You have basically on the left a single phase, so basically one wire that will hold the electrical information. Basically, I'm not really an electrician, so maybe when what I say is not really accurate, but the idea is there. And for triphase, you have basically those three wire, so it allows more power into the cable. You always have the ground and the neutral, but what matters is the number of phases. So you can have two phase also, but most likely it is either one phase or three. Sorry. So here it is for residential, so I will just use power balance, and then I will click the number of poles. So basically number of poles is the number of phases. I do not know why it is called that way, but I believe that maybe it's to differentiate between the phases in the project and the phases in the electrical systems. So I do not know, but I'm guessing that is because of that. So for example, I will just link a number of poles. So once again, as Jackie said, you can use the share parameter files, but for the sake of the video, do not you do it. Here, and this is a bit, it's not controversial, but you can have different way of doing it. I will first do it as instance, and I will show you why it can be interesting to do it that way. So I link it a number of phase, so it's only one because it's balanced. Power factor is usually lagging. You can be leading too, but usually most of the time it's lagging, so you put it that you keep it that way. Then you have the load classification, which is also important, and we will see why, because it has the information for the panel. Here you put it as type, you don't need to have it as instance, never. This I uncheck it, you let it unchecked usually. Then you have the voltage, same as number of pole. You can put it as instance. So I will put it as instance, and I will show you why in a few moments. Apparent load, I already have a parameter here. Apparent load is basically the wattage. The unit here is volt ampere, but it's the equivalent to watt. I believe the difference is between the theoretical load and the actual load. So sometimes volt ampere, I believe, is for theoretical and actual is for watt. But maybe it's the opposite. I don't know. Here you also have power factor, which basically is good here, coefficient of utilization. It's basically when you have one, it's basically used at 100%. If you, for example, you have electrical fixture that is used as 95, for example, you put 0.95 here, for example, here. But we will let it at 1 because usually it's at 1. So then you have here same description and utility. So I won't put the description here, but I believe it is always the right way, but I do not necessarily have the time to do it every time. So here I have my information that is linked from the connector. Those two ones that are instance, but they can be of type, and then most of the time they are of type. And you have the load classification. The load classification is important because this is the information that goes into the panel, and it also allows you to do some calculations, some specific calculation. So here I choose the lighting because it's for lighting. But for example, if I have an HVAC equipment, I put this power for HVAC classification basically. And then I have a demand factor. So the demand factor is, and we can go a bit in detail about it maybe. I will put lighting like that. It's basically for calculation, and it simply say that if you have this fixture, we will always calculate the load at 100%. But usually it's not that way. You can have maybe 100 lighting fixtures, they will never be lit at the same time. So you can say, well, it's not the case. So I will simply here set some steps where for that one I will do, well, if I have more than 10 but less than 20, I would simply calculate all at 80% or all at 60 if I have more than 20. I can calculate it by quantity or by load, and say if I have maybe from 10,000 watts, I say 100% and etc. etc. So that's why it can be important to have a proper demand factor. It's really for calculation, so really advanced MEP stuff. Here I will set it that way. So now I have nothing else to do about the connector. Everything is okay. But for example, if you have something for industrial and the the company, the BPM manufacturer tells you, well, it's a tri-phase stuff, then you go to unbalanced. If you go to unbalanced here, before you uncheck that one, just to be sure it doesn't mess up with any kind of stuff, and then you put number of poles as 3 by default here, and you link and you link each one of the apparent load phase with a parameter. same as we did with 1 for the balanced. As you can see here, if I put 2, which is also possible, I will not be able to link the phase 3 because I only have 2 poles, 2 phases. But for our example, we are on power balance. So here I will go back to power balance, I will relink it to apparent loads, and then I will go into the parameter of my family and put that at 1. So also I will put a default voltage, which is 230 in France usually. That means that the minimum is 220 and goes to 240, but we say that is 230. So here is okay, and then I'll load this back into my project. Okay, I overwrite it. And then I will simply see, it didn't put the information for the, sorry, I will have to select everyone. So click here, select all instances in entire project, and I will put everything at 230. Okay. So as you can see here, I do not have the proper classification too. It is put at others. So I will put it as lighting, and okay, so there is already a demand factor that is set up, basically lighting for residential. Okay. So as you can see here, I have those ones that are instance parameters, so I can edit it directly. And why I put it as instance is because when I will create a power system, this pops up. So it simply allows you to choose the number of poles and the voltage directly upon the creation of the system. So basically I have 1 pole, I can choose those 3 voltage because the voltage distribution that is set up in the project only are linked to this number of pole 1. And if I choose for example 3, then I can only have this one. So that's why I put it as instance. But usually and most of the time it is put as instance. So we go back to the family. I can see reasons for it to be put as instance. For example, if you have a family that can go from really a small load, for example 15 watts, to maybe 50,000, which is unlikely, but it can happen. Well, that will allow the possibility to have different poles according to this load. So that one, for example, would probably be for three phases, but that one here would probably be with 1. So this is a case where I believe number of pole and voltage can be instance, but most of the time the load is set up in a range that makes it that the number of poles never changes. So as it is most of the time, basically, sorry, this is that one, I will put it back as type. But as you can see, the pop-up is quite nice because you create a system and then you can choose the number of poles just to be sure. It's kind of a reminder. So it's kind of a nice feature, but it's really up to the product manufacturer, and it should tell you which way it should be. So here you can see I go back and this is grayed out now. So obviously it changed the default voltage. I will go back here to 30, and then everything is properly set up for me to create my system. So here my panel is at 1 pole and 230 volt, and so if I create a system I will be able to link it into my equipment. So this is really important because if you have fixtures that do not share the same type of distribution characteristics, then the panel will not be able to be used. So here you can create lighting groups because it's easier to manage your lights, but this is not the subject of the video. And then I create a power system. So now I have a new system with only 1 fixture, obviously. Here it has already set it up with the proper panel because there is only one that is existing, I believe. But here I will simply create and edit the circuits. So I will add the circuit here, and as you can see the panel is already selected, but if it was not, you just had to put here that one. You see, as I created, it did not ask me to have a number of poles or a voltage value because it doesn't need to. As the information is as type, then it will read the information of the fixture, then check if it is already existing in the panel. And if it is, then it will link the panel directly into the system. So it's easier, maybe. So that's why most of the time it is a step. So now I have all my information in my system. So I will see what I have, but it is a bit different than the ducts and the plumbing, because now it's about loads. As you can see, they share the same voltage, which is logical, and 3 times 60 obviously equals to 180. So everything is okay. As you can see in my panel, I have some information, and the most important one is that one. As you can see, you have lighting connected, and you have a total of intensity here. That intensity is calculated obviously with the number of apparent load. So if I change that one, oh no, it will change everything because it's type. So let's just say that I change this 80. I should really do it with this, but no. It will change here. So it's really automatic, and then here it will change the intensity of the circuit. So it's really good. That's something that Revit to do really well, and that's quite nice to have. So here I can go back into the family and change the load classification, and you will see the differences. So here I put it at HVAC, and now in my panel yes, you can see HVAC connected. So that's why it's really important to have the load classification into the fixture family, because then you are able to let the user have a proper family without doing any kind of manual post work by themselves, so they can fit their projects. So I go back here, lighting. It's back to lighting. So it's really great. Now that I did this, I can do some wiring. Well, wiring isn't really 3D thing like you can see here. It's mostly in 2D, and it's mostly symbol lines. So here I go in plan view, and oh, I do not see my lights. Okay, maybe it's a view range thing. Okay, maybe 240 or not. No. Maybe a visibility graphics thing. Yes, that's it. Electrical, lighting. I would see maybe there are other one there. Lighting device maybe. Wires. Okay, that will be okay. Okay, so this is good. So as you can see now, I can see it. I was probably in my architecture, so obviously that's why it was not displaying this. So here I can select the system here. So you see, you have the symbolic representation of the system, but we can also do it and have it hardwired basically. So I selected that one here, and as you can see, I can now choose the type of wiring. So if I click here, up, it gives me some symbol lines that are really wires, and indeed you have some information, some electrical information. So I can basically change the type here and put it as chamfer, and here increase the number of stuff that is in it. So I can change it maybe, oh no, do it directly like that. Okay, for example, I want it that way. It's really it's really symbolic. It's not that you doesn't see it in 3D. Nothing. So for this one, I know some electrician who likes to have their electrical stuff in red. So you can not do it the same way that we did at the system. You really need to go into wires here and change the color. Okay, so that way you can have it properly set up in your project. Same for lighting fixture, etc. But really, we don't need to do more. This is really what you can do with electrical stuff. Just one thing, because I did not forget. Here you can see a conduit. You can see a conduit connector. So I can basically change the position, etc. I want, and then I can draw the conduit. So as you can see, and as you will see, if I click on this here and I go into its properties, I have absolutely no electrical information. So it's for electrical stuff because the conduit usually have some wires inside, some cables inside, but it's really not some MEP stuff. So that's all really when it comes to MEP connectors. I believe I have said everything that I could. But really, if you can have it set up into your object, that will really do some quality work and really try to pester your developers so they do it directly without you having to check this, basically. But if this is well, then you have everything that is already preset for a proper project. Well, that would be all. I hope everything was clear. And if you need something else, some more explanation, just hit me on Slack. Au revoir.